Alright, so we are coming back to note 3, example 2. So just right below the introduction of the loops rule and junction rule. So example 2, what's the value of V1, V2, and R2? So the question asks us to find these three things. V1, so that's the voltage drop on this one. V2, where's 2? 2 is down here, so V2, and also R2. Oh, R2 is also missing. That is surprising, but that's also missing. Okay, so we want to find these three things. Okay, V1, V2, R2. So we don't even have R2. Now, a lot of time when you're doing circuit question, the first thing you do is try to find equivalent resistance and then figure out the total current. But in this case, we can't even use that step, which is usually the very first step that we have. Now, the reason why we can't even use this step is because we don't have R2. And if you don't have R2, there's no way. Okay, there is no way that you can actually find equivalent resistance. So therefore, we must have something else. Okay, we must be doing something else. Now, I apologize, but this question has a typo because I actually forgot to type in one piece of information. Without that, we actually don't have enough information to solve this question. Now, what I forgot to write is that the current on this right hand side branch, which I am going to, this is part of the question's given value. Okay, I just forgot to put it. So can you add that in? I4 is 0.3 amp. Okay, so I4, you know what? I'm going to put it in here so that I can have more space. So I4 is 0.3 amp. So we actually have the current going through R4. This is a given thing that I forgot to put in the question, so I apologize. Okay, so that's it. That's the only thing given. Okay, so how do we start this? I don't have total resistance, so I cannot find total current. So I mean, sometimes, remember from each of these, I will label. So for example, here I would say, R total and I total, right? But so that's V total that we have in there. So that number is V total already. But I don't have I total and I don't have R total. So that's one out of three things that we have. So that doesn't do anything. Right, that doesn't do anything. On resistor number 1, we don't have current, so that's one out of three things that we have. So that doesn't do anything either. And resistor number 2, we have nothing, so don't even look at that. And resistor number 3, we have one resistant, and that's it. We don't have V3, and we don't have I3. So, well, right. So which way does current actually go? So current should be going this way. So like that, go in, go this way, current go this way, and then there's a split up, and then rejoin, and then go back to the battery. So it should be something that looks like this, but we don't have a lot of these information. For example, I3 is missing. Okay, so it's split up into I total. So I total at some point, split up into I3 and 4, and then rejoin. There's also current going into resistor 2 called I2, but hopefully you know a bit familiar with the rules by now. I1 and 2 is the same thing as I total. That's before any splitting, right? So all the electrons, all the delivery guys and girls are all still on the same route. That's before splitting. They will split over here at the junction point and then rejoin over here at this junction point and go back as I total, come back to the battery. Okay, so the only one location where we have anything going on is R4 right now, because I have I4, R4. That's 2 out of 3 things in the Ohm's law, so I can figure out V4. Now, how does figure out V4 help us? The question doesn't ask for V4. I don't know. I'm not kidding. I don't know how it helps me, but I know that that's not the only thing I could do right now. So we'll do the only thing that we could do, which is figure out R4. So step 1 is to look at R4 and try to find V4 from it. Okay, so V4. So V4 is equal to I4R4. Okay, so in this case, it's going to be 0.3 multiplied by 20, or 20 multiplied by 0.3, which is the same thing. So it's 20 multiplied by 0.3, which in this case is 6 volts. Okay, so V4 is 6 volt. Now for anything that, anything that we discover or we calculate, I'll put it in red. Okay, so V4 is 6 volt. So at that location, I have everything. Wait a second. We have a rule. Remember, parallel branch. This and that is parallel branch. Parallel branch have to have what the same? They have to have their voltage drop the same. This is 6 volt. This is also 6 volt then. It has to be the same. You know what? I'm going to write I already wrote Y3, so I guess I will put V3 here. So when I write 6 volts, it kind of look nice. Parallel to this one. Parallel branch, same voltage drop, same pizza drop, right, in this case. So now we have parallel branch. V3 is equal to V4. So V4 is 6 volt. V3 is also 6 volt. There we go. Okay. Wait a second, that means our resistor number 3 now has our 3 thing. Cool, because that means I can figure out I3 then. So then we're going to switch gear into resistor number 3. So we're trying to deal with whatever we could, right? Right now, the other area still has nothing that we can actually use. So now, let's resistor 3. V3 is equal to I3 R3. So in this case, I'm trying to get I3, which is this right here. So we're trying to get I3. So what is I3 equal to? So I3 is equal to, so we have to divide the voltage, which is 6 volts, by the resistance, which is 30 ohms. Okay, so that is something that we can easily do in a calculator. Is equal to 0.2 amp. Okay, so I3 is done. We still haven't answered any other questions. You know that, right? We're doing whatever we could. That's the game right now. So this is 0.2 amp I3. Okay, so I wrote it down here. Wait. There is a junction point with only one unknown. Now, see, I3 and I4 are going in. Okay, I3 is going in. I4 is going in. I total is coming up. So I only have one unknown in here. According to what we call the junctions rule. So we're going to apply junction rule right now, which is the current rule. So junction rule. I total must be I3 plus I4. So in this case, I total must be 0.2 plus 0.3, which is 0.5 M. I suddenly have I total. Oh, that's nice. If I have I total, I can actually now move on to the battery. So I have I total. Now let's put the I total back here, which is 0.5 M. Okay, so I total is 0.5 M. Ooh, that's another place where I have 2 out of 3 things. See how these type of question kind of you need to proceed to different parts one by one. Right. So I have I total. Now with I total, I can actually figure out, you know what? I think doing equilibrium resistance. There are 2 ways to do this question. I think the faster way to do this is by doing the following. Okay, so I have I total right now, which is the same as I1 and the same as I2. Same route, no splitting, right? I1 and I2 should be the same because this is one row. If I have 5 people going here, I should have 5 people going down to R1, passing by R1, and I should have 5 people passing by R2. They only split up because later on, right? I know it's not 5, it's 0.5, but you know, you get the point. 0.5 people sounds weird, right? Okay, so that means at this location now, I do have 2 out of 3 things. Now you might say, Mr. Chang, why didn't you continue with what you were thinking earlier, which is figuring out our total? Figuring out our total doesn't really, okay, it helps actually. Okay, think about this. If I do R total right now, I'm going to do these in, I'm going to highlight in blue. If I do R total right now, then what is my next step? I will say, okay, so R total should equal to R1 plus R2 plus whatever you get as the equivalent R34. Okay, you have to find the equivalents R34 in parallel and then series them with R2, R1 to get R total. So if you have R total and R1 and you series and you do a parallel R3, R4, you could use it to figure out R2, but that's a long way. I think my way is faster if I ignore R total and do this right now. Okay, so what I'm going to do is I'm going to use I total, which is now I1 and I2, which mean I can actually figure out the voltage of V1. Okay, so I'm going to do resistor number 1. I'm going to find V1. And then I'm going to apply loops rule to it. So I'm doing R1, working with R1 right now. So V1 is I1 R1. In this case, that is 0.5 times 18. This is 9 volts. Haha. This is 9 volts. V1 is 9 volt. Oh, actually, we answered one of the question. V1 is one of the item that they want to find. 9 volt. Okay. We'll list them out later. But I know V1 is 9 volt now. Okay. So how does that help? I'm going to apply a junction to this. I'm going to take this junction, right? Not junction, sorry, a loop. I'm going to take this loop, which is green. Okay, so ask yourself, how many Pizza Huts are here? Only one. Where is it? At the battery. Ooh, right here. How many customers do you have in this delivery route? 3 of them. 1, 2, 3. You might ask, what about R4? That's not my problem. R4 is responsible by another people or another person, my coworker, right? My coworker will go to R4. I only have to go to R1 and then stop at R2 and then take a left turn, go to R3 and then join my coworker and do this whole thing again. So R1, 2, and 3 is my delivery route. I pick up how many pizza? 60 pizza from the battery, right? 60 volts, 60 pizza from the battery. How many pizza should I drop in total? Or deliver in total? 60 pizza. How much did I drop at R1? 9 pizza. How much did I drop at R3? 6 pizza. But I pick up 60 pizza. So how much should I drop at V2 then? At R2? The remaining amount of pizza. So that's actually 45 if you're doing your mental math. Okay. So now I can use this loop, right? So this is the loops rule. So I'm going to write down that we are actually doing the loop rule right now. Okay. And that gives us this green loop, right? This green loop. And the green loop is telling us that V total, the voltage gain, total voltage gain, is equal to total voltage drop, which is V1 plus V2 plus V3. Now, I pick up 60 pizza. I drop 6 pizza at customer number 1. I drop, sorry, didn't read the number. I drop 9 pizza at customer number 1. I drop 6 pizza at customer number 3. How many pizza did I drop at customer number 2? 60 minus 9 minus 6, right? In this case. So V2, which is another thing that the question is actually asking us to find, is 45 pizzas, 45 volts. Now this is one of the questions that we had to answer. V1 was the other one, but we did already. We just kind of wrote it on the side. There you go, V1, right? Okay, so now I just have to figure out R2. Okay, so R2. R2D2. Sorry for the Star Wars reference. Okay, so now finally we can have R2. So we are working with resistor number 2 at this moment because we actually have 2 out of 3 things again. Now I have current and voltage. So now one more Ohm's law, we are done. So V2 is I2R2. Okay, so V2 is 45 volts. I2 is 0.5 amp. So what's R2? Now, a little bit of algebra will tell you that R2 is 90 ohms. 90, 90. And that's it, everyone. Question is done. Now, you might look at this question and say, okay, that's actually very complicated. Yep, I pick an example that is complicated. I mean, what is the point of doing the easy stuff, right? When you're learning how to do this, with me right now, of course, I pick examples that are a bit more complicated than, what you might expect, for example, on the homework. Okay, so we'll move on to the next question. All right, take a break. All right, so I have a good break. How about you? I just paused the video. I actually did have a break and had a sip of coffee. I know in the video that you're watching right now, it doesn't seem like any time has passed. Okay, so now in this question, the last example is going to be, so we want to find the voltage drop across the 8 ohm resistor. We want to find the voltage drop at that location, which is going to be called V5. I already P-labeled them, so you can pause the video and label them if you want to. So I want V5. Given that I have for example, now this one going in, should I call it I5 or I4? Because it's actually going through 5 and 4 at the same time. So I guess I'll call it I5 at this location. And then it's split up in here. So this is I3. Okay, so I3, I5, and then there is also a V, right? V3. All right, there you go. V3. Okay, now look at this question. We have every single resistor. What do we do when we have every single resistor? Usually, we'll do a total resistance followed by total current. Total resistance, equivalent resistance. Step 1, we have to deal with this branch, the parallel branch first. Before we do that, we need to combine these two, the R4 and R5. These two need to be combined first. These two are in series right now. So if you want to combine them, it will just be R4 and 5 in series. Okay, so step 1, we want R4 and 5. So step 1, we need to combine resistor 4 and 5 in series. So R4, 5 is equal to R4 plus R5 because they're in series, and that's just equal to 12 ohms, right? So that's just 12 ohms. So you know what? I need more space. There we go. So there we go. And that will be 12 ohms. Now, okay. So what about R345? What if I want to combine R3 into it? Now look at this, which I'm going to erase later on. So this is R3. And I have now combined these two into that one, which let me call it R45 for now. Is this in series or parallel right now? This is in parallel, right? You cannot have one electron that goes to R3 and 45 at the same time. So these two are in parallel. So if I want to find it, I will have to do these two in parallel. So right now, this R3 is 6 ohm, R45 is 12 ohm. So I have to do this in parallel. Okay, so 1 over 6, 1 over 12, 1 over the answer. Usually, so how I do this kind of question is, in a calculator, if you have a calculator, right? Okay, so you know what? Let me write down the equation. So R, I guess, 345 is 1 over R3 plus 1 over R45. Now, in case you forget from last day, the way to do this, the quickest way to do this is to actually, is to do something like this. So you know R3, so you do 1 over 6 plus, so 1 over 6 plus, now 1 over the 4, 5 together, which is 12, right? So you add the two, and then you just 1 over the answer. So most calculators have an answer recall button. That means the 0.25. So you do 1 over that 0.25, and you get a 4. So you get 4. That's it. That is it. So R345 is 4 ohms. Okay, so 4 ohms in total. Now I'm going to erase that because we actually need the space. Okay, so R345 is 4 ohms. Then what? Okay, then what? Okay, then we actually need to add the other two. So we have now, again, I'm going to draw something that I'll erase. So we have the battery here, R1 here, R2 here, and I have combined everything in here. Okay. So I have combined everything in there into this one giant resistor, which is R345. Now, are these three resistors in series or parallel at this point? They are in series because you can actually go through all three of them without leaving your loops, right? Okay, so these are in series, so let's add them. So to get R total, we're now at the point where we can actually get R total. So R total is R1 plus R2, so they're in series. So we just add them. So R1, R2, and 3, 4, 5. Okay, so R1 is 5, R2 is 11, R3, 4, 5 is 4. So add them together, that's exactly 20, I believe, right? So 11 plus 4 and 5, that's exactly 20. Okay, so that's 20 ohm. So the total resistance in this circuit is 20 ohms. So here, total resistance is 20 ohms. So we can fill in the battery's location. Oh, that's 2 out of 3 things. You're very happy when you see 2 out of 3 things while doing circuit questions. If you have 2 out of 3 things, you know that there's something else, there's something you can do. Okay, which is Ohm's law. Ohm's law, right? Okay, so Ohm's law battery, let's go. So step 2, we're going to deal with the battery using Ohm's law. V equal IR. In this case, they are total. So voltage is 120. Okay, so 120 volt equals to I total times total resistance, which is 20. So I total must be 6, right? 6 amp. Haha, I total is done, 6 amp. I total is 6 amp. And wait, I total is the same as I1 because 6 people leave the battery, 6 people go to the first house, right? There's no splitting yet. And then 6 people go to I2. Cool. Okay, unfortunately, it's not 6 people going to I5 or 6 people going to I3 because they will actually split up. So we will have to deal with that. Okay. Now, but at least we know I1 and I2 is exactly the same. Okay. So let's write that down. So step 3. Okay. So I1 is I2 is I total, and they're all 6 amp. Okay, good. Now, we're inching closer and closer to what we need. I know what do I really want in here at the end. What do you really, really want in here at the end? Is V5. I don't think I have mentioned that. V5 is actually our question for the first part. V5 is our question for part A. So if I want V5, can I get V5 right now? Well, unfortunately, you can't. So what you know right now is there is an I total, which is 6 amp coming in. Okay, I total of 6 amp coming in. And it's splitting at this location into I3 and I4. Now, it doesn't have to be 3-3 split. It could be 2-4, it could be 1.5, 4.5 split. So you have no idea how much is actually going into I5. That means you still don't have 2 out of 3 things to figure out the V5. So what can you do? Well, in that case, you can do a loop. Now, but it's easier to do a loop if you have it combined. So we are going to do something in here like this. So we're going to redraw this diagram. But with the R4 and 5 combined. Okay. All right. So I'm going to redraw that diagram really, really quickly. There we go. Doesn't have to be like really nice looking. There. And there is a parallel branch, but I'm going to combine these two. So there we go. Right. Now, so what I want is this one, R4, 5. Okay. Now, so what do I know right now? Okay. So what I know is R1 up here. Okay, so R1 up here. and R2 and R45 and the battery. Now, in terms of the voltage, I know the voltage. I can find out the voltage drop on all of them. It's quite easy. For example, what is the voltage drop on V1? I have two or three things, right? And V equal to IR. And I have my I and R sitting on top and below it, 6 and 5. So 6 times 5, 30. So I'm dropping 30 pizza here. Cool. Do the same thing for V2. So I'm going to, because I'm saving space, I'm actually doing some of these questions in here. Okay, so V2. V2 is equal to what? I2R2. And again, I have V and I right next to the numbers. I2, R2. So R2 is 11. I2 is 6. 6 times 11 is 66, right? So V2 is 66 volts. Okay, so now I know this looks like a mess right now, so I'm going to draw them in this picture. So V2 is 66 volts. V1 is 30 volts. Battery is 120 volts. Okay, so 120 volts. Now, I'm going to do the pizza deliver loop. This loop right here. Like this. Okay, so in this loop, I have to deliver 3 customers, right? I have to deliver to 3 customers. The first customer took 30 pizza. The second customer took 66 pizza. The first customer took an unknown amount of pizza. But how much pizza did I pick up from Pizza Hut to begin with? 120 pizza. So whatever does not drop on the first one and the second one must be on the third one. Okay? That's how you get it. Easy, right? This is which rule? Loops rule, because we just draw a loop. So this is the loops rule. So we're going to apply loop rule right here. And that is saying V total is V1 plus V2 plus V45. Sorry, label it wrong. Let's call it V45. All right, V45. Now, how much is that? Well, that's is going to be 120, and V1 is 30, and then V2 is 66. V45, the voltage drop on 4 and 5 combined turns out to be 24 pizza. Okay, so here the voltage drop is 24 pizza. Now, and R45, if you remember, we actually do have the 45 is this one. It's 12 ohm. So this is 12 ohm. This is 2 out of 3 things. This is 2 out of 3 things. That means I can actually figure it out. I45. Okay, the amount of current that's going here. Now you can call it I4 and I5. Remember, we were struggling to name them earlier on because I said, well, it's going through 4 and 5 together. So I don't know if it's called 4 or 5. It's actually I4 and I5 exactly the same, or I45 if you want it to be. Okay, so it doesn't matter if you combine it or not. That is still the same amount. So, wait. Now why do we need that? I need I45 so I know how much current goes through that. Okay, so this I45 is going to be, so I will use Ohm's law. Okay, Ohm's law again. So now we are dealing with the resistor 4, 5. So 1, 2, 3, 4. So 3 is this step. So 4 and okay. So let's do a step 5, which is going to be involving the I45. Okay, so V equal IR, except that they are the 4, 5. Okay, so voltage is 24, resistance is 12, so current must be 2, right? 24 divided by 12. So I45 must be 2 amp. Okay, I45 must be 2 amp. Now, how does that help us do the rest of the question? So I45 being 2 amp, I45 is the one that goes through here. Doesn't matter if you combine it a lot. So this is, now I'm going to erase that later on for clarity. These are the same. The amount of people that go through the bottom path is exactly the same regardless if you combined it or not combined it, right? If you combine these two in series, you'll have the same number of people going down compared to this. These are exactly the same thing. So that means I5 is also 2M. Okay, so I5 is also 2M. I4 is also 2M in this case. So 6M go in, 2M go down, so 4M goes up. If we lead that, we can write it down, but we actually don't need that number right now. Okay, so this is that, which is I4, which is also I5. Wait a second. We have 2 out of 3 thing on the resistor, number 5 now. Voltage is what we want. I have current 2 amp and I have resistance 8. Da 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 da. Number 6. So step number 6, which is the last step for part A, is done. So V, okay, so V5 is I5, R5. Okay, so V5 is I5, R5. I5 is 2 amp, R5 is 8 ohm. 2 times 8, 16. There we go. There we go. 16, 16, 16, there. Okay, now that is part A. Woo! Took us a while. Now, if part A took that long, part B will be longer, right? No, actually, this is not true in a circuit question. In a circuit question, once you get to a point later on, it's actually very easy to find anything else because we have almost solved everything in this question. Now, so what is part B asking us to do? So I just need like a tiny bit of space for part B. Okay, so for part B is how much is the power usage at the 5 ohm resistor, which is this one. So the power usage at this. Okay, at this location. So first of all, power, I can find it. It could be this equation, P equal IV. It could be P equal I square R. It could be P equal V square over R. So I can use any one of these 3 equations. So what do I have right now? Actually, I have everything. I have I, 6 amp. I have V, 30 volt. I have R, 5 ohm. I actually have everything. So just use the simplest one. Now, which one is the simplest one? Of course, the first one without any of the square is the simplest. So that's it. Let's do it. Power on the 5 ohm resistor. So power 1 is V1I1. Okay. So voltage is 30 volt. Current is, I think, 6 amp. Yep, 6 amp. So 6 amp. So power, the 180 watts. So the amount of energy consumed in that resistor every second is 180 joules per second. Okay, so that's it for the 2 example. All right, I'll post the homework on the blog posts as usual on the courseware page. And bye everyone. Take care.